I just.
So when I do this kind of in facet speak, since we lost about 12 minutes of the period, if I wanted to represent the length of this curve from A to B, and I said, oh, that's about it, you'd say, nah, it's about it, but it's not so close. And I said, all right, and say, is that better?
A little bit.
Then you'd say, well, we can make it even better, couldn't we?
Yeah.
So make a few points. Yeah. So now, if we added up the lengths of those little segments, line segments, it would be a lot closer to the actual length along the curve than would the original secant line. So that makes sense.
That makes sense.
How many of those little segments do you think we're going to have? It's a smart group.
Stop.
So, if we were looking at this here for the secant line there, we could find the secant line. I'm not so interested in the slope. This is going to make you think of the slope. But the delta y would be how much y changes. Delta x would be how much x changes from the first point to the second point. And that would be a really terrible approximation for the length. Yes?
Yes.
What I'm going to do is draw along this a tangent line at A. Tangent line just tangent to the curve. And this is our tangent line. Let me just write that here. Tangent line. Very different than the secant line, yes? And of course, for the tangent line and the tangent, we learned is the same as the derivative, dy dx. Garbage? If we look at dy dx as the quantity dy over the quantity dx, this little section would be the dy, and this little section would be the dx. Please note, delta x and dx identical. Delta y, dy, not identical. Capiche? And in fact, for points so far apart, one from the other, the delta y would be the dy would be a terrible approximation, one for the other. Imagine, if you would, that the points were not so far one away from the other. Let's say we're along the curve, we're here now. I changed to a different point, I'm going to change the color. And now I drew that same sort of little triangle. And that big length there is which of those? Is that dy or delta y? That is?
Delta y.
So I got both answers. One is right, one is wrong. That length that I made from the curve down to the horizontal is?
Delta y.
The dy, in fact, would be this smaller distance, yes?
Yes.
But you could see that for this point closer, the dy and the delta y aren't so far apart, are they?
No.
What if we picked the point along the curve even closer to our original point, and then we drew and we looked at our delta y and our dy, they're even closer one to the other. Yeah?
Yeah.
So imagine, if you would, that the original point and the new point are really, really close one to the other. Yeah? In which case the dy and the delta y are just virtually interchangeable one with the other. I'd like to take that situation and imagine we're at that original point there and we're looking at an enlargement of the picture where that 1-2 points almost touching one another, so close. But we enlarge it, we zoom in on that so that the points look like here and here. They're really almost touching each other. You with me? For that scenario, if we drew this little quote-unquote triangle, dy and the delta y are virtually the same, and for all intents and purposes, this little curvy part is so small that we could even interpret it as if it was a line, as if it were straight. and our dy, our dx, and what I'm going to refer to as ds. S is going to be seen as the length of the curve. Let me write that over here. Length of the curve S. Please note I'm using a script S. I'm using a lowercase script S. Please do the same. S's like this look a lot like 5s. Please try to do the same. I'm going to say what I said before we go to the next step. Since we're picking a point so close one to the other, and we're zooming in on it, it's almost true that this is a little triangle. If this were a little triangle, what relationship would exist between these three quantities? Max?
I found
And what would it be?
it would be ds squared plus dy squared equals ds squared.
That would be correct. We there so far? Okay. Do I want to do that square root now? Yeah. So ds then would be the square root of plus or minus the square root of dx squared plus dy squared. So far so good? I don't even know what the next step is going to be. Yes, Jeff?
Get rid of the negative,
Great. Why?
because it's a length.
Exactly correct. We there?
Yeah.
We got it, but we're going to do it. Suggested. Anyone know what the next step is? We don't really want ds. That's the differential for s. We really want s.
Integrate both sides.
Radians. So that's how we'll undo, that's a new word, undo the ds, integrate both sides. There's something wrong with our integral however on the right side, poor thing.
That's too bad.
That's a big problem, but there's something, and we're going to have to fix that, but there's something else that's really bad about it. And I went over this on Friday, said it's impossible. Michael?
We're missing a d, anything ds, dx,
Yeah,
dy.
so it's meaningless in this one, yeah?
Yes.
We're going to have to create it. And we're going to do that by very carefully making an adjustment. We're going to take that expression on the right side and multiply and divide by the same quantity. I'm going to do it twice actually. I'm going to take that quantity and divide by the square root of dx squared. Yes,
TX squared is not dividing it, that's not,
it's inside.
it's in the, it's inside?
Inside. I just divided by the square root of dx squared. That's bad algebra, unless we fix it.
Either multiply it by dx or
By what?
ds.
And that now created our what's it called, directions on which way to integrate with respect to a limit. So we did something totally okay. Divided and multiplied by the same quantity. Almost finished. Of course, dx squared over dx squared is 1. And dy squared over dx squared could be seen as dy dx quantity squared. Please note that dx is clearly outside of the integral. We're going to integrate from some a to b wherever they tell us to start and end. And we did it. We just derived an expression for s, little s. By the way, we're going to be using a capital S for the surface area, so it makes a difference. Make sure you use the lowercase s for length of the curve. And I just want to point out, there's another form, actually, 2 other forms of this. Had we divided by dy squared and multiplied by dy, what would this have looked like? Eric?
dx dt squared plus dy.
There's no dt. There's no t in it.
So dx dx dy's
Yes,
squared
that's right,
and plus 1.
yes. And it would have been
dy.
sometime, the rest is the same, of course. If your function is x equals stuff with y's, it's convenient to find the x dy, yeah? And you use this form. And now the limits a and b, of course, would be 4y. If your function is y is equal x's, then this is about a formula. Use 1 plus dy dx. It's easy to find dy dx. You use whichever one is appropriate for that question. There's a third form when the functions are written in parametric form. So, parametric form, there's a parameter, that's the letter that links the x and the y. Oftentimes it's t. So, in that, remember you've seen parametric form, maybe x is equal to the sine of t, you're making this up, and y is equal to the cosine of t. Let's say that was it. Here it would be easy to find dx dt and easy to find dy dt. So we kind of like this to have dx dt's and dy dt's in them, wouldn't we?
Yeah.
How could we accomplish that? Going back to the same original one, what would we be doing to this original one? Yanina?
Divide by dt squared,
And?
and then multiply by dt.
Exactly correct.
Put it in the square root.
Yeah, she meant the square. Okay. What would be that last form? I'm going to write it over here. It would be the integral again from a to b. This would be for a t this time. Josh?
Square root of dx dt squared plus dy dt squared times dt.
That was great. Excellent. Please again note that the dt is outside of the square root. Please be careful in writing what is inside and what is outside. Don't extend this too long so it's not clear. You have a question?
I'm sorry.
So we spent a little bit of time in deriving these expressions. I want to apply them now. And I'd like to try to go over some homework if I can. So let's do this first example. You guys are great. 1/3 Before I write what I'm about to write, which of the three forms do you think, let's go the first, second, or third, which would be applicable next? I would agree. To cement that in place, you're actually given the beginning value for x and the ending value for x. Please write the integral that you would use to find the length of this curve. You don't care what the curve, you don't know what the curve looks like, but for this curve, we want to find the length of the curve from x equals 0 to 3. I'd be happy if you just wrote the integral expression. So somewhere on the side, you're going to figure out what dy dx is, yeah? As soon as you've written it, say, I'm ready. Freddie. Was that Ruth?
Just set it up.
Just set it up. Still right now. So there must have been a problem in writing UIDX. That's what's taking so long.
No,
It's stuffed to the 3
no
halves.
problem.
So what do you get?
1/2
Yeah,
1/2
stuff. X is
Stuff.
D
to
stuff.
the,
so that
1/2 times
times
6.
you can't build
There you go.
so you got it?
Yeah.
Okay. So that 3 got divided out, yeah?
Close.
Okay. So our s, again lowercase s, from,
0
Zero,
to
three.
3.
please note there's no pi involved in this. Square root of
1 plus x squared.
Maybe you can actually square that right now, so I don't have to write it squared. Could you square it?
Squared.
X.
Even without, how about this? If I said square AB, what would you get?
It's gonna be squared.
Thank you. Yes?
Yes.
That's what you get. If I said square 3y, what would you get?
9.
So I'm asking to square A times B. What would you
X
get?
squared.
X squared